hi to all, and I'm glad to be here again, and thank you for staying here. I don't know what is like in other halls, but yeah, I hope more people will arrive till at least at the middle of the talk. So a little bit about me is written here, and there is nothing special. And I am part of the Radiona Makerspace, so I come from Croatia, Zagreb, and we are like non-profit organization, and with cool stuff, workshops, and everything. So I'm also like CEO of the Intergalactic. I do open source hardware, open source software, and mainly open source things. So in previous lecture you heard about from Michko about the GateMate, so I will not make this slide super important. But I want to mention that this is like not expensive FPGA, and it is like really good substitution for something that we had before, that is like ECP5. So lower version of ECP5, like 12F, is like almost equivalent with like this one, but this version of GateMate, even the smallest one, because you know it's like you can have 1 or 4 dice or 2, it has the SerDes, so that makes like big difference if you need the SerDes part. So that's like something that is valuable to this FPGA. Maybe Michko didn't told that this FPGA also has like different voltage levels, and what is the official that it works only like up to the 2.5 volts, but there is like testing running in the with 3.3 volts, and we can say it is like non-officially 3.3 volt compatible, so it will age by more. It will age more, so at some point the lines will like go away, but that time is really long time. So brute force, like we have the Patrick from GateMate has from Cologne chip has the aging process started a year ago, and with like brute forcing all the pins, and it is still like a year ago it didn't age enough to that we notice any difference. So in normal usage, I think you can use it for like many years. Michko also mentioned the evaluation board for the FPGA. That's the official board, so I will not talk about this one. But there are there are some community boards, so that we didn't mention. So one is like Trends Electronic, that also has the like it is done like system in module, so it can be used like a modular board. Machine Die Colch is like really good board that also has some features that we implemented before in our own boards. And yeah, there is like one Raspberry Pi Hat board, and there are like some other boards that are not finished or have like specific purpose, so they are not like mentioned here or on the Cologne webpage. So before our project started, there was no like good toolchain, no good examples, and the FPGA toolchain, the part that is like place and route tool, was actually missing, and we were missing the hardware. There were like few boards like Korsh, but it was not. No one did examples for them, so you mostly got the FPGA board like the Olimex one with the blink LED, and that's it. So from that you needed to figure out your way and fight with the place and route tool. That was not like super fun. Also I want to mention like in the Gwen's repository, so he created the repository with the demo for the VGA and DVI. So that was mainly our starting point for the project. We applied for the project, and again, like in many other of my talks, I want to thank to NLNet Foundation, because they are like really good partners and financiers for the open source hardware, software, and everything. So we just applied there and got the grant for the openCologne project. And the project was quite wide, so we wanted to, in collaboration with Chili Chips from Bosnia, we wanted to have something similar to like ULX3S mist samples, so to have lots of examples that could run on the board, but at the end we wanted to have also the board, so that was the main goal. You can read more about the projects of openCologne in the link. So it is the main part of the project was actually getting all the samples running, because that was like the hardest thing, because toolchain was not ready for the samples, so that was like really crazy. So you have like, okay, you have blink LED working, but after everything else was not actually working, so it was like quite hard to be, and all the first examples was done with the proprietary toolchain, and it was really hard because you needed, for each sample you needed to call like Patrick, so that he can like fix proprietary toolchain to have something inside of it and to be fixed and to get it working. So I also like want to send big thanks to the Chili Chips, and younger generations are like with us and they are really great partner in crime for the open source tools, and for any project I would say contact them, like if it's FPGA related or gateware related, they do really good job, they are really collaborative, and yeah, contact them and your problem will be solved. So in these projects, the task was to port as many as possible samples to the ULX, from ULX3S to the at first to any GateMate FPGA board. But we wanted also to continue our work on system on module chips, system on module boards. So as we did before, like ULX4M, it was like fully compatible CM4 board. So we wanted to continue that and give this new number 5, so that we have like ULX5M that will be like GateMate with like that is CM5 actually compatible. So now we have like CM4 and CM5 compatibility. Also, like we wanted to explore more examples that are in like for the example folders of the ULX3S. So we wanted to add and give a little bit more to the community than it was asked by the projects. So the starting point, because the cheapest actually board that was available was the Olimex board, and our starting point was just to buy the boards and just to start with that one. But this board is actually really good, and we can do many things with it. So especially for the like retro stuff, because like we have PS2 connector, we have VGA, we do have some RAM that is for some things usable, for some things not. It is also good that it has onboard programmer, so we can use like dirty JTAG with Raspberry Pi Pico and just like program it with ease. It also have like voltage selectable levels that in our case was not important, but when you need it, like this board is great for that usage. Also good thing is that it has lots of connectors, so we can extend this board in many ways. So when we started the project, we wanted actually to test everything that we can on this board and then create our board, because well, something maybe like can be impossible, so I don't want to like invest a lot of time in doing like impossible things. So we started to think about what extension could we add, and we started like to think about 1, 2, 3 extensions that would give us like a big range of the for the like testing purposes, but we actually ended with the little bit more of 3. So at the like end we have like enormous amount of example boards for the ULX, so it is like complete set of the boards that you can use on the ULX FPGA. So maybe interesting things is that we wanted to add HDMI that cannot be called HDMI because it is not like it will give you the picture it is actually the DVI output, so we call it not even DVI, we call it the GDPI, and that is really good stuff. So you can have like multiple video outputs, so even like VGA and like three DVI outputs. We also wanted to have like on the ULX3S we wanted to have like USB, so we added here like 2 USB ports. We also wanted to experiment with gigabit Ethernet, so I added the gigabit Ethernet, and I think that important thing is like was to add like this simple I/O thing with the like gamepad, and actually it's 8 LEDs, not 7, so that we can like have it like on our boards like the complete like byte, so that we have like 8 LEDs and see the complete byte, what is going on with the byte. But we had it at first with like just with the buttons, but then we switched to the like joypad, so because it was like super cool to have joypad, and later the colleagues from Chili Chips when they added the game, we will see it later, it was like quite usable to have it like this. Also Michko asked me to add microbus, so yeah, microbus was added. It is just like level transition, because at that point we didn't know that GateMate can tolerate 3.3 volts, so it is like switching the voltage from any level you set, like 1.2, 1.8 and 2.5 to 3.3 volts. We also did that the same thing with like dual PMOD extension, so that actually is almost the same. It is using the same translator chips, and it is like we are using the faster one than on original board. So we use the ones that are like 100 megahertz, so we can do things that are a little bit faster. We also wanted to test the like MIPI standards, so like Raspberry Pi camera is really interested to us, so we also added connector to Raspberry Pi camera. I also want to mention like little bit like hacky way of doing small boards. So when I ordered like lots of extensions at once, so it was like 10 extensions, the stencils were like quite expensive to order. So I was checking on the like cheap laser, so I have some cheap laser at home. So how precise can I like actually do the stencils, because it is much easier to do it with stencil. Okay, I can always like solder one board or 2 boards, but with like many boards it is really easy to do it with the stencils. So I found that I can do it from the like cardboard and the paper, and the quality is actually really good. So I managed to do all the boards, even the like HDMI connector. I managed to solder it on the to put the paste on and not get like bricks on the connector. So it is really like a good hacky way of doing the stencils. And I use just like normal paper, but not white one, because the laser will not cut it very well. So I use the colored one, and the orange color was for, because it's a blue diode, orange color was the good way to go. So if you we'll do some board like that has like small stuff. You can use the paper stencils. And yeah, with paper stencils I managed to assemble the whole set of the boards, and I was like slowly getting to the point and to the testing phase. So okay, the simple I/O was like, it is just input, outputs and stuff, but all other things are like, yeah, we need the cores. So at that point Chili Chips already had like basic samples and already understood what tool can do, cannot do, and we started to, some things from my side and some things from their side, we started to implemented the gateways to the FPGA. So at the like end, we ended with lots of documentation. So they always do like examples with like really good documented examples. So each example has also simulation, so it is really useful to enter each folder of the and see what is inside, because it is all documented with the pictures and with the running stuff, and they really do a great job in this section. So make sure you visit the wrong link, but to visit the Chili Chips GitHub section. I also got some things from the ULX3S running, because at first I didn't, I couldn't make the USB core running, so I needed to port the like simple like protocol analyzer, I would say. So like hex decoder for the USB to see if USB is even like live, or it is like what is going on with him. So I did that, and this was done with the proprietary tool chain, and at some point I got the USB running. So actually HDMI and USB and like simple I/O was like confirmed, and that was like working. Also I have checked, and translation board like dual PMOD like was working, and a good sample to see like the speed and stuff was to get LED panel running. So I saw that there are no like errors on stuff. So yeah. And Chili Chips in background did like lots of examples, and actually the perfect thing that they ported they already had like Tetris Array on the other vendor board, but they ported it to the GateMate. They had like first version of the simple I/O, but later they ported it to another version, and it is like two-player game FPGA done completely in the FPGA, so it is Tetris for two. Okay, so I had everything like confirmed that I wanted, so all the hardware was like done. So the next part was like to create like system on module board. So the starting point was given, like I would call it the template, was given by the Cologne itself, because they had some templates. I also used the Olimex board because it is fully open sourced, and I could use the fan out from the FPGA from them. So I mixed the open template from the Cologne and the Olimex fan out to get like starting point for this board. And for the like interfaces, I was thinking that the GateMate board doesn't have enough pins to cover like all the interfaces that CM5 can have. But yeah, we just like moved some of the interfaces and got like this list of what we will do. So we will have like 8 LEDs, 3 buttons, SD card, lots of GPIOs that are like routed as a differential pair. Like we will have these two CSI, DSI ports, and so we can have or two cameras or one display, one camera, or whatever combination. We also, in this version, we wanted to have USB-C, as micro USB is like on our previous board, and it is good one because it is like small one, but yeah, it is better to be like USB-C compatible. Also on this board we wanted to have SDRAM because it's like super cool, and like lots of retro gaming stuff is already ported and has SDRAM, so we wanted to be somehow use that. We wanted to have gigabit Ethernet, also flash was needed, and yeah, we also wanted to have external LVDS clock because it is basis for the SerDes part. For the like onboard programmer, we didn't go into it because on ULX4M it was the USB bootloader is enough, but I wanted to add like JTAG over GPIO, so I use like four GPIO pins for the JTAG, so that's the thing we do. So you can always like plug some extension board to the Raspberry Pi header and program the board if something goes wrong with the bootloader. And yeah, on the suggestions from the Cologne chip was to have like switches that will be selecting where do you boot from, so is it from like flash or not, so I also implemented that. And yeah, after some work, this is not the final version, I think this is V2. After some work I got like everything connected, and yeah, ordered the board, and like had first like 3D rendered and ordered the board, and then the like problems started because yeah, we need to get samples running, and it was like not easy. So I can confirm that this board was given like 5 volts on each power rail, and it wasn't killed. So even on 1.2 volt, it can withstand 5 volts for a short time. There is even, when I talked with Patrick, there is even like document that is describing how much can it suffer. So they did also like that investigation. But yeah, many things were like wrong on the first version. But somehow, yeah, we cleaned up. I cleaned up this in the like on the board itself. So I got the HDMI out, and that's like that was like the phase where I was like happy with the V2 and starting to do like the V3 that will clear all the other issues. So later the Michko added many examples, so now we have like ton of examples that are mostly for the Olimex board because it is like VGA, but I had like on GPIO I connected the VGA output, so I got some games running, so it is like really cool that we can already have some games. Also like V2 is now assembled in like, we have five pieces assembled. Here are like 3, and one will be tested by the Gwen, that is the author of the OpenFPGA loader. One is Michko will have one and test it, and I will have one, and the Cologne Chili Chips will also have, and Patrick did his own version of the board, so he assembled himself, and he tested most of the stuff. We still don't have like Ethernet running, but we do have like mem test passed for the SDRAM. So we still don't have also Linux running because like we didn't have time to boot it. It is also only running on the Kolsch board, and I didn't test like we don't have PCI tested, but everything else is like almost ready. So our next project that we got granted for also NLNet is to get PCI Express running on the ULX5M. And yeah, for the end, I really want to thank to the many people, and to many of them that helped me in the development and in like talks and community support and stuff. So really big thanks to Josic HQ, and special thanks to Patrick, because he is always available and he's helping me a lot in the this is the first time that FPGA vendor is like collaborative and doing stuff with me. So really big thanks to them. Big thanks to Gwen, because he is like also really responsive and does like lots of testing and stuff, and like he's the author of Open FPGA Loader that we are using. Thanks to Olimex, and the communication with them was really perfect. And also thanks to all the fabulous open source tool chain and our really big community on Discord and wider. So yeah, thank you, and I hope you like the presentation. And yeah, here is the information about the project. So yeah, that's it. So thanks.
Thank you very much, Goran. We have time for one, maybe two questions tops, because we have like 4 minutes left. Does anybody have any questions? No questions? Okay, so that'll be all. Thank you, Goran.
Hvala.